Generally, if speed goes beyond a certain limit, a trip valve in the overspeed trip mechanism automatically closes to stop the turbine. There are a variety of arrangements for overspeed trip mechanisms, but they all operate on pretty much the same principle. Basically, if the turbine overspeeds, the shaft's centrifugal force will cause the trip valve in the overspeed trip mechanism to slam shut. When this valve shuts, it cuts off steam to the steam chest and stops the turbine. Also associated with the overspeed trip mechanism is a hand trip lever that the operator can use to trip the turbine by hand. Manually releasing the lever's latch causes the trip valve in the overspeed trip mechanism to shut and stops the turbine. Whenever the trip has been activated, either automatically or by hand, it must be reset manually before the turbine is put back into operation.
Overspeed trip. It is designed to stop the turbine if the constant speed governor should fail. This device is extremely important, since a steam turbine will run wild and blow up in seconds if not controlled or shut off. A very important part of the overspeed trip mechanism is this trip pin. The trip pin on the turbine we will be working with is located in the governor case, which is fastened securely to the turbine shaft. It is actually a pin that extends through the shaft, a pin that is weighted on one end. It is restrained by a spring on the opposite end of the pin from the weight. If the shaft turns too fast, the centrifugal force of the weight overcomes the resistance of the spring, and the weight is thrown out until the head of the weight extends past the edge of the governor case, as shown. The pin then makes contact with the trip plunger and forces it down. When the trip plunger moves, it unlatches the hand trip lever, leaving the resetting lever free to move. A spring then pulls the resetting lever down, forcing the trip valve to close. When the valve closes, it cuts off the flow of steam, shutting the turbine down.